Okay, welcome back to part 2 of this series where I'm going to be going over this roadmap website. So I'm going to be teaching you everything that you need to know in order to be a successful developer, and more so in the case of web design or software engineer. So I work as an AI engineer and I have my PhD in computer science, and if you want to know more about what this series is about, then you can go back to part 0 to watch that. But basically I'm going to be going over the practical details of everything that you need to know in order for you to be more confident when you go to find a job, computer science or software engineering, or if you're someone who is just starting off and you don't know where to start. This video is basically walking you through everything. So this website goes through all the topics of what you need to know in order to be a developer. And for today's topic, we're going to be going over the front-end developer topic. And then right off the bat, we're going to start with this little blurb here of what is a front-end developer. So a front-end developer is basically everything here. Everything that you're seeing is everything that, like all these buttons here, what color they are, who created this button here, everything that you're seeing, everything that's being rendered on your browser. There's UX, so there's UI and there's UX, and this is a concept that I had a difficult time understanding. So UX is basically how you're using the UI. It's a mental model of how the user perceives using the system. So, something like if I were to navigate to other sites on this website, they created like this little hamburger menu here. This is a hamburger menu because it has 3 lines. It looks like a hamburger. I would need to hover over it and select the next site that I want to get to. So that is a user experience of how you explore the website. So if for example, I was exploring this website myself, I clicked on all roadmaps and it brought me to this different looking website. And this is maybe like a slight nitpick of this website, where if I go to backup page, it goes to this dark blue website that shows all the topics. I would think that by clicking this button, it would go back to that site. So in that case, that user experience of like how I'm perceiving this website, it's a little bit off. So yeah, so that's user experience. I definitely think this website is a great resource in order for people to up their skills in being a developer, learning more about being a software engineer. And obviously I'm using it for this tutorial here, this series. So the main things that you need to know in order for you to be a front-end developer is you need to know HTML. HTML, it's basically the programming language in order for you to render things on the screen. If I open the developer tools here, the shortcut is Command-Option-I on Mac. You can also click on these 3 buttons and then go to more tools and developer tool. Then it shows you this HTML of what the page looks like. This is what tells the browser how to render the content that you're seeing on the screen. Also, this developer tools here, you need to know what this is. This will help you a lot. I'll get to it later on in the tutorial. But basically, this is HTML. CSS is code that tells the browser what that HTML looks like. So for example, I have this text up here. I open back my developer tools, and I'll talk more about what this is later. But if I click on this button, I can see the HTML that created this text. You guys can't see my finger, but I'm pointing at it. CSS tells the browser how I want that content to be rendered. So if I want it to be a red color, then I'll change the CSS to make it red. And that's basically it. That's CSS. And this, a lot of you might be wondering, is this changing the website for everyone else? No, it's not. This is only changing the website for my view. JavaScript is also necessary. It's not completely necessary in order for you to create like a static web application, so something like a blog that doesn't have any buttons on there. JavaScript is needed in order for you to add some dynamic content into the system. So if you want to fetch data on command, when you click on the button, then you would use something like JavaScript. And these are scripts that you can run that does some extra logic in order for the system, like the browser, to fetch more information from another API and then show it back to the user. Or If there's any like animations that are being done through JavaScript, then it needs to run through that logic in order to calculate how things are moving. Maybe you have a animation of the solar system, then JavaScript tells those HTML elements how to move on the screen. That's what you need to know for JavaScript. Okay, so this also lists all the skills that you need to learn in order for you to be a successful front-end developer. So there's a lot of things that are listed here and already went through HTML, CSS, and JavaScript. Understanding accessibility. So accessibility is a large component of being a front-end developer, especially if you're building it for a large number of people. This is something that Apple cares very deeply about. So if you want to get into a job for Apple, then you need to increase your understanding of accessibility. When you're building your web applications, you're building it for a ton of different users to use your system. And there's things like you need to develop it for people who are colorblind. So you might need to use certain colors that fits most of the people's spectrums of what colors they're able to see. And there's also things like integrating speech into it. So if there's people who they are unable to use their fingers, so if they can just use like a speech enabled system, you're improving the accessibility of it. Another case too is if someone who isn't able to see the screen, you can improve the accessibility of the program by adding captions or making the system able to be read aloud. So this allows your application to fit a larger number of people. And also you can do stuff with like languages, making content easier to see, improving the contrast of the text on certain backgrounds. This is just everything that improves the look of the system. Version control systems. So if you want to be a software engineer in general, GitHub is basically, Git is used for accessing actions or things that you need to do on GitHub, and it is like the command line interface of interacting with GitHub. So if you have your application, your code, so you're coding, GitHub is used to store your code onto their servers. If you have a team of developers who you're coding with and you need to share some code with them, or you are fetching from the same repository, then GitHub is what you're going to be using to store all of that code in order for them to use. And GitHub is a great tool because it comes with versioning. So GitHub allows you to store code at certain time intervals. So when you're pushing code to the system and at some point maybe it breaks like another part of the system, you can roll back or go back to a different time interval of when you save the code before you pushed your changes. You can go back like a version. Okay, so a responsive design is basically, if I go to my developer tools again, if I click on this button here, then you can test how responsive the system is by viewing it on mobile devices. How does the system react to switching on mobile phones? Is all the content able to be accessed? Is it pushed out of like different boxes? Is it overflowing out of the divs or something? And you can also view like different interfaces of how people might be interacting with your website. So if you are able to fit a lot of these different interfaces, then you have a very good responsive design for your interface. And also if I do something like this, then you see the text as it moves, right? This is a very responsive website. That's what that means. Okay, so next on the list is user experience. We already talked about that. You can learn a lot about user experience. This is everything about how a human interacts with the website. So I know this is a lot when people are building a web application and it's unavoidable. So like when you're building a web application, you're so used to going through the whole website, interacting with the elements, getting from point A to point B. So you're very familiar with how you use the website. But then if you give the website to someone else and you tell them to get from point A to point B, they might not know how to do that. Whereas you as a developer, if you've been developing the website for maybe like a couple weeks now, for you it's like you are super familiar with how the website works and what you need to do in order for you to get there. That's why it's important to have some people who are testing the website to give you like some fresh eyes in order for you to build the application that's intuitive for a wider range of people to use and not just for yourself. So SEO stands for search engine optimization. So this is basically how people are finding your website through Google. So if I search for something like Alex Hormozy offers, I already did it, then if your website is search engine optimized, then whatever I search for, it'll place it higher within this list. Obviously, you can't optimize your websites for fitting all the keywords in the world. It has to be things that are relevant to what your website is about. So something maybe very general, gym wear, clothing. So Barbell Apparel, ASRV, and Gymshark, they do a good job with search engine optimization, where their content gets loaded more towards the top. And then you see sponsored results, which is people who paid for their websites to be closer to the top. RESTful APIs is basically how computers communicate over the internet. Testing and debugging is just testing your code. I noticed this a lot, not just with myself, but with certain other also big name companies, that people don't test the code as much as people advocate for it. At least for me, I'm someone who's creating a lot of prototypes. I'm not pushing a lot of code for production ready people to use. I haven't gotten to that stage yet, but testing is basically like setting up cases where if people are requesting certain parts of information, is it being rendered correctly onto the screen? And this roadmap here has some tools that are listed that allow you to do that, which I'll get to later. And then debugging is basically whenever there's something that's wrong with your code, you can add some log statements. So as you're developing your code, you can make a log of what is actually happening and how variables are being passed around in your code. This makes it so when you open up the developer tools and you're logging something, and then you go to your console, say that I have a button here that isn't working, I can add a debug statement that fires every time I click on the button. And if that console isn't printing anything, then I know that function is not being called. Okay, so dev tools, it's listed here. This is a very useful part of the browser that will make your coding life in front-end development easier. So the main tools that I use on the developer tools is Elements, which allows me to see all the elements that are being rendered on the screen. Of course, I showed you the mobile view, and you can mess with the CSS. There's also the console, which I showed you is used for adding debug statements to the system so you can fix your code. And then there's also network, and network allows you to see everything that's being fetched from the website. So if I click on network and I click on this first topic here, you can see there's a few things that were being fetched from the server, and we'll get to what that means later. So if I click on any of these and I click on headers, when I clicked on that button there, this first entry here requested information from this URL. So if I copy this and I put this on, if I search it up, then it returns an HTML document of what I am seeing here, right? What this is doing is the front-end development code. This is you as a front-end developer. You're going to be writing how I want to show that information that I'm getting from this server. So say that you coded this website and then you make a request to a server and I get a response back. I get this information here, and on the front end, I want to view, I have a template that I want all the information that looks like this to be viewed in this way. That makes sense, right? If I click on this next one, I'm getting another set of information and I'm using that same template and I'm viewing the information in the same way. Hopefully that makes sense for you all. Okay, so frameworks. Frameworks are basically a high-level abstraction. If you've went back from part 1 in this series in computer science, I explained to you guys the high-level abstraction of Python and C and assembly code. This is basically the same thing, where if you were to code in plain JavaScript, vanilla JavaScript without any frameworks, then you will need to do things like manipulate the DOM. And when I say manipulate the DOM, when I open up this Elements tab to see the HTML is basically, when people say DOM, it's this HTML file here. And when you're using plain JavaScript in order to augment things or change things that are within this HTML code, then you need to be very low level precise on grabbing this HTML tag here, and I want to grab the div from this, and then from that div maybe I want to fetch that tag here. So it's very cumbersome to grab information from this DOM. But if you were to use something like React, Vue, or it's not listed here, but there's Angular, all of those different frameworks abstract a lot of that low level details away so you can access that DOM easier. Web performance. So web performance is basically just how your front end application is performing. Is when you load up a website, is it taking a long time? When you have a lot of people that are requesting the websites, if you have a lot of people accessing your website, what are the load times like? If you are loading a bunch of information from the backend, instead of showing all the information all at once, you can do something like lazy loading, which is you're loading information on certain events, like when the user is requesting additional information from the backend at certain events that the user does. For example, if I had the very long HTML page that's loading a lot of data, instead of loading everything at once, I'm only gonna load maybe like this first part here. And as I scroll down, those events are being captured by the code, and it can detect like certain places where I am in the browser, and it can fetch that information dynamically using JavaScript. Okay, TypeScript. So TypeScript is basically JavaScript, but when people declare their variables in TypeScript, then they have to also include the type of what that variable should be. Is it a string? Is it a Boolean? Is it an integer? Is it a float? Okay, so TypeScript, you can imagine it. This is useful for development when you have people on the back end who are maybe creating a schema or the way that the data should be represented, and you have someone like a front-end developer who is receiving the data from the backend. It's easier to develop when those properties of how the data looks like is matched. So if I have another front-end developer who's also working with me, we can define or create a set schema of how the data looks like. It makes it easier for the other developer to know what the data needs to look like in order for it to work. Okay, so that took a long time already, but we're going to progress on with the rest of these topics here, starting with the internet. So what is the internet? How does the internet work? So the internet is basically this infrastructure that someone created in order for people to share content online. That's basically everything that you need to know. This tutorial isn't going to go through every low-level detail of how everything works. This is every practical information that I think that you need to know in order for you to start developing and get a computer science job and be more confident. So that's all you need to know about internet. It is how people transfer data online. What is HTTP? HTTP is a protocol that people have standardized the way that browsers communicate with each other. So if I have a set way of receiving data, I built this browser, I know what the data that I'm receiving of what it's going to be looking like. That is what HTTP is. Domain name. So domain name is basically how people name their websites to a format in order for it to be easy for people to understand. These domain names, actually the term is called resolved. So it resolves to an IP address. This domain name is probably connected to 36.244.2.112.32, and then there's a port that's associated with it. So when I look up Roadmap.sh, it resolves to some sort of IP address, and it connects to a port where I access a certain page on that website of where it's being hosted. And that brings me to the next question. What is hosting? Hosting is basically a computer device that sends or gives information to anyone who is requesting it. So if I have a computer, say I wanted to host this website, roadmap.sh, I created this whole repository, and then someone like you wants to access this website. So I'll buy a Mac Mini, and then I'll put it on my desk, and I'll program that Mac Mini to host this website that I created. So people like you, if you want to access this website, you would request information from this Mac Mini, and it's going to send it directly to your browser, in which your browser knows how to interact with this website or knows what data is coming through this protocol. Okay, so next is domain name system and how does it work. I already explained it to you, where a domain name just resolves to an IP address. And then there's certain providers, so when you access a certain website, that knows how to resolve those domain names, and that's all you need to know. Okay, so browsers and how do they work? A browser is a contained environment that basically whatever code that is receiving from a web server who's hosting data, it just renders things in a contained environment. And when I say that, this is also an important concept to understand. Your browser is just something that knows how to view the information. It doesn't allow any access to any of the hardware components of your system. So that makes it so when people are sending data to us, everything is within this contained environment. People can't send malicious code to my browser and grab all the information from my website. In order for that to happen, I would need to click on a malicious link, and through my interactions with the website, it might upload things to the website, and then it sends it out to whoever has malicious JavaScript that is within their code. Okay, so we already went over HTML, CSS, and JavaScript. These are just the hard skills that you need to learn in order for you to be a front-end developer. Version control and version control system hosting, I already talked about this. So Git and GitHub, they're basically the same thing. It is the command line interface in order for you to interact with GitHub to save your code for other people to use. And you don't need to learn Git in order for you to be like a successful front-end developer. There's something called GitHub Desktop, which is a graphical user interface that allows you to interact with GitHub. So let me give you an example. Git Desktop. Okay, so this here is GitHub Desktop. So instead of you needing to know how to use the command line interface and needing to remember like git init, git clone, git add, you can just use this GitHub Desktop and interact with GitHub through interface here, which makes it easier for you to know what is happening or to learn it very quickly instead of learning all the commands that are shown here. And I think the only cases of when you need to know how to use Git commands is if you are doing like special things like maybe going back a certain commit history, or if you want to programmatically find changes that are within your Git history that you need to go back to, and so on. GitLab is listed here. I haven't had any experience to use GitLab, but this is basically used for what is known as continuous integration and continuous deployment. And what that is basically infrastructure that you can set up in order for your system to get deployed easier. So for example, if I was building this website and I wanted to deploy the changes to this production server, if I had continuous integration and continuous deployment setup, immediately when I push changes to my main branch in GitHub, if I were to do git push origin main, and instead of me logging into the server to pull all the changes and do all the deployment, if I have CI/CD set up, then it would already deploy everything for me. Okay, so that's what CI/CD is, or that's what I'm assuming GitLab is useful for, because it lists CI/CD. And other CI/CD applications is also that I have experience with is called Jenkins. And Jenkins, you can set up pipelines in order to, like, whenever you have like a complicated deployment process, you can set up a whole pipeline of how you want to run like test cases and how you want your code to be deployed to production. Okay, so package managers are basically a management tool that you can use to install different libraries to use within your application. So for example, I can go to the NPM website and then I can search up some libraries that I want to use within my application. A common one might be something like Leaflet. So Leaflet is a visualization library that you can use to just import within your project. You can download it and you can use all of the components that are available within Leaflet. If I go to the official website, hopefully they have a map here. Okay, yeah, so this is what Leaflet is. If I just use npm and install it within my repository, then I can copy paste this code and then put it into my project, and it'll create this map here. And this is really useful because if you didn't have a library like Leaflet, you would need to create code on creating this whole interface using HTML to create like the canvas. Maybe you need to grab some information from like satellite views, and you have to add some JavaScript for detecting events on when the user moves the map and zooms into something that they want to see. Okay? So that's what a package is, or a library. And there's several package managers available. I think these purple check marks show you what is recommended from the person who made this website. For some time, I think NPM was very popular, then people switched over to Yarn, and I think NPM is starting to get popular again. You can pick and choose which one you want to use. I think each one of them are used to track your dependencies. One of them might be better than the other with being able to resolve like how dependencies depend on other dependencies. For example, if I download Leaflet, it might have several other libraries that it is importing within its own library. So everything that I download from Leaflet, it also depends on other libraries. So there's a lot of interdependency links going on where I might be dependent on a library that Leaflet is also dependent on, but it might be like a different version of it. Okay, I hope that makes sense to you all. So CSS frameworks CSS is basically how you would style the HTML elements that people are seeing on the board. Frameworks is just like a high-level abstraction that takes away a lot of the low-level code that you need to do in order to customize what it is that you want to build. For example, Tailwind is a CSS framework that you can download and use within your project. And then instead of making custom CSS, like very low level, if I were to select on this web security, I can see that it highlights the HTML component within this HTML document. Okay, so let's take for example this element here. So if I were to select the element, let's click on this element, web security, and then let's maybe highlight this, and then this is the HTML element, and this is what the style I'm going to be giving it. This is the CSS. If I do color red, then it's going to change the color of the text on the screen. But if I do maybe Tailwind CSS images example, you can use different classes, and instead of doing the whole background color or changing just the color of the text, then you can use shorthand little code snippets like this. So it just makes it a little bit more easier in order for you to customize the elements. You also have access to red 100 where you can have different shades of red, whereas if you were to do this with regular CSS low level, then you would need to go to something like Coolors, and you need to get the hex. I think it's I forgot what these are called, but you need to get this number instead. And then if you were to get like different shades of red, then you would need to type some of these in, which could be a problem if you're trying to build like a website that has the same consistent kinds of colors throughout your whole project. You would have to go to this picker here and remember where color exists. Instead of just using like Tailwind CSS, you have access to all these different shades of red, which is the same color but with different intensities. Tailwind isn't the only one out there. I believe most AI tools have a lot of data that it was trained on Tailwind and probably like Material. Those are two popular CSS frameworks that I've learn when trying to learn this for engineering stuff. And there's also Chakra UI. So Chakra UI is another CSS library or CSS framework where you have access to like different components. They have like boxes, and then the boxes have like certain properties on it that make it easier for you to customize your website on like how you want it to look, as an example. Okay, all right, learn a framework. So here it lists like as we also seen this, there's a CSS framework, but there's also a JavaScript framework. So as I mentioned in the beginning of this video, there's different frameworks that are available. Okay, so the next step is learn a framework. And we already went through it. It's like a high-level abstraction of coding, but this is specifically for JavaScript. So this is a framework for CSS. These are frameworks for script. And from what I've seen from applying to over 2,000 jobs, I've seen a lot of people who are looking for React and Angular. These are two popular frameworks that people are using for JavaScript. I think most of the time, there's a lot more jobs that are hiring for React. So if you were to pick a framework to learn, then I would very much recommend that you pick React. Okay, Linters and Formatters. So here is 3 different formatter. I'm not familiar with Biome, but Prettier and ESLint I've used in all of my projects. So Prettier, so when you go to work with other software engineers, there's certain formats that people conform to in order to make the code a little bit easier to read. And when people are pushing code to GitHub, and you as a developer, if you all conform to the same format, it'll be easier for you guys to read through the code. So let me give you an example. An example of an inconsistent, unstandardized way of formatting your code, I use 2 spaces for my tab, and then I have another software engineer who uses 3 spaces. So then when we go to merge our project together, or when we're reading each other's code, some of the indentations might be a little bit off. This is also a huge problem if you guys are using something like Python. So Python is dependent on those tab, the number of spaces within the tab. So conforming to the same formatter is something that you guys should do, and Prettier helps you guys do that. So ESLint is a linter. So a linter is something that goes through the code and it maintains like a consistent style, or finding errors, or what is known as code smells. The first time I heard about it was in a software assurance class, and it's basically, you can see here, surface level indicators in the code that suggest a deeper design problem, such as a function or class that is too complex, bloated, or difficult to maintain. So an example of this is like long methods. So if you are building like this class, maybe you're building like this shape class that has a method within it that is to calculate the area. And then say your area calculation is 500 lines long. This is called a code smell because your method shouldn't be that long. Your method should be, when you're coding in general, your code should be very singular in what it's supposed to do. If you design a function, it should only do really like one certain logic. It's things that researchers have found within code that make the code like bloated, or make the code hard to read, or make it very complex. So you want to avoid code smells as much as possible. So going back to ESLint, finds inconsistencies within your code. If there's an unused variable, or if there is an import that might be resolving to a wrong path within your project, or say you're using Typescript, everything needs to be typed, right? But you can also use this keyword any in Typescript. So instead of defining all of your variables with very specific types, a bad thing to do is just to type everything using any, which is like a catch-all for what you want to define your variable as. And if you're going to use any throughout your whole application, then that defeats the whole purpose. So you might as well be programming in JavaScript in that case. Okay, next we have module bundlers. The only bundler that I'm familiar with is Vite, and my only knowledge about what a bundler is, basically it's a framework for setting up your project. There's a lot of these tools that are available that take care of a lot of the low-level guesswork, pretty like monotonous, like setting up the React project or creating like a template on everything that you need to have in order for your React code to work. Vite, and I guess these other module bundlers here, allow you to set up a project very quickly. You don't need to know too much about what specifically they have functionalities for. At least in my opinion, with my limited experience, that's what I think. Testing. So the only testing that I use in my code is either Jest or Playwright. Like I said in the beginning of this video, I am a AI research engineer, so a lot of the things that I work with is basically prototypes. And a lot of the times when you're building prototypes, or if you're building applications very quickly, you don't have time to test everything, especially if I'm building applications for 5 to 10 users. It's not very big, and these prototypes are typically very short and they're not going to be used long term. I skip a lot of the tests where I probably shouldn't. I do have a project that I'm working on now where the people using it are getting very interested in its capabilities and they foresee themselves using it long term. I have a lot of things implemented within the project. So what I do is I use something like Jest. So since I'm using React, Jest is a easy to use testing framework where it's easy to set up like test cases to see if things are rendering correctly on the screen. Okay? And in Playwright, there's Playwright and there's something called Selenium. So Playwright and Selenium, from what I know, is it mimics a person using the browser. The people out there who are thinking, how do they build a bot that does certain things online? There's a lot of bots out there. For example, if you were to wait in line for a pair of shoes that are coming out, they're very limited. You would use something like Playwright or Selenium to mimic opening the browser and waiting for the line or the queue to open in order for you to purchase the shoes or put it in a cart or something. Okay, strategies. Okay, so all strategies, I would say that this is more so of a backend thing. Most of the time when I'm building something with authentication, I'm using an API for it and I use Firebase. So Firebase has a very generous basic tier that allows you to store like user accounts and store data within their servers. It could probably support like 500 users, which is a lot. And Firebase has a very easy step-by-step guide on setting up authentication within your website. Web APIs are basically if there's other applications that are available and they have access to like the data that they have, maybe they have access to like services. So say I was a user and I wanted to access climate data from a researcher. I have a researcher who is at the university who has a server. They set up a server and they made it publicly accessible. So if I wanted that data, I would contact that person. I would say, hey, what's the API documentation on how my computer could request information from your server? And then he would give me that and I would request the data. And then I have, as another example, say I wanted to compute some things within that data. So I have access to OpenAI that has this API that is available. So I can use the servers from OpenAI to perform some large language model processing within the data that I just received from the university researcher. And that's basically all you need to know for front-end development on web APIs. Okay, on to web security. So web security, the only two that I know on here is Coolors and HTTPS. So let's start with HTTPS. So this is basically the same protocol as before, regular HTTP, but with the S here, this is secure. So it sends the data as encrypted. So previously, when the internet was created, HTTPS wasn't available. A lot of the people sent data through HTTP protocol, and that was a huge issue. Data was being sent in non-encrypted when people were transferring data to each other. So there's this concept in web security where there's like it's called man-in-the-middle attack, where there is one person who wants to send data to another person. There is a man in the middle who is listening in on the communications from person A here, and it's also listening from person B. And say that person A is sending like their username and their password to person B. This man in the middle can intercept that package, grab all the user information, and then normally they would send that information to person B, where it's basically seamless, where it doesn't look like this man in the middle accessed the data for malicious purposes. So what HTTPS solves is that data that is being transferred from point A to point B, now it's all encrypted. And the only person who knows how to unencrypt the data is the person on this B side who's receiving the username and the password. And they use hashes or public keys in order to resolve that encrypted data into something that's usable by the server. So Course is a parameter in place where people who are setting up servers, they can set who accesses their server. So if I click on it here. So if I have a server that's set up and people want to access my data and say my data is highly protected, I don't want just anyone accessing the data. I only want my front-end client to be able to access the data. I can have a parameter within my server that says that only clients that are from this certain IP address can access the data within my server. And that's what CORS is. So it's like a protection layer of saying who can access your data or not. Okay, next on the list is server-side rendering. So I don't have too much knowledge around server-side rendering. The only thing that I would know on server-side rendering is if you have a website that maybe it's very intensive on the front end to do the rendering. Say that there's astronomy data, there's a lot of stars that you visualize. Instead of sending all the data to the front end, telling it to render all of those points, say that there's a million points on there, what you can do is you can render it on the back end side and you can stream the data to the front end and take care of some of that processing. That's the only way I think that what server-side rendering is. I might be wrong, but that also makes sense. If you have this very intensive process, then you don't want to send it to the front end to do all of that rendering because it's going to take a long time for them. But if you have a very powerful server that not a lot of people are accessing in the first place, then you can save some compute for the client to do the rendering and then send it to the front end for viewing. Okay. SSG, I don't have a lot of knowledge around SSG, static site generators. So I'm just going to skip that. Type checkers. TypeScript is basically, it's JavaScript, but you have to type everything throughout the whole project. There's design systems. So design systems is basically everything that you see in UI. It has to do with things like accessibility, how people are accessing your website. There's also certain design methods. The one I'm most familiar with is contextual design. So this is a user-centered design process where when building out your application and when building out the requirements of what you need to build, contextual design is like a framework that when you go to collect requirements on what is required to build out the application for your clients or for customers who are going to be using your website, you're going to be doing a very fine-grained interview with them. You actually go to their workplace and your day-to-day processes, how they work, what things they have trouble with, what it actually looks like within their workplace. So this gives you a lot of context into everything that they have issues with within their workplace. It just gives you more information on what guides your requirements on what you need to build. In part of this, they have something that's called like an affinity diagram, where after you go and interview the people there, you connect back with your team, and then whoever is like the note taker or people who visited the clients, you would create this affinity diagram that basically explains all the different nuances or challenges that goes on within their workplace. And then you work as a team to define what is the best course of action for building out the website or the application that they're going to be using to make things faster within their workplace. And then there's also other design systems out there. A lot of that I know is user-centered design. You can do your own research on design systems and see what you find out. Design systems, I think it's one of the most important things that you need to know as someone who is a front-end engineer or doing something in product, because this isn't something that AI can take away from you. This is actual intuition on what you should tell the AI to build. So this isn't doing anything with code. This is just guiding the whole purpose of what the AI should be doing when it's coding for you. So there's deployment here, where there's multiple different ways to deploy your application. This is basically, how do I make my website that I built accessible to people all over the internet? And these are just several applications here where they make that process easy to deploy your project. Okay, performance. So the only thing I know on here is like DevTools. Let me give this a refresh. So a lot of these aren't available for me. Hopefully that's not the case for you. But the only thing that I use on here for checking performance is DevTools. You can see the network tab. So if I go to the network tab, and then I can see how long it takes for this page to load. And then it shows me like how long it takes to load, and it's showing me what API calls it's doing on the back end, or what API calls it's doing to fetch that information for me. There's a performance tab on here, which I haven't used a lot. But if you're building an application for conversion rate optimization where the website needs to be loading very quickly, then this is probably a tab that you might want to look at more. Another thing too is a lot of the time Shopify, or if people have Microsoft Clarity, I believe, or Google for Analytics, they have a lot of these information on the analytics that'll show you if your website is slow or not. Okay? Accessibility, we already went through that in the beginning of the video. It's basically just making your website easy to use for people who might be blind, or people who are unable to use the keyboard, or people who are colorblind. This is just making your website accessible to a wide range of people. Okay, web components. So web components are basically components that are reusable. So you see that these boxes here, they all have a similar format or a similar style to them. Someone didn't write this button 50 times on this website. What they did was they created one style of this button, and now that button is called a component. And then that component is just reused a lot throughout this web page. That's basically what web components are. So you want to be building your applications that are very in this web component pattern or paradigm, where they can be reused throughout the whole application. And then for some reason in the future, I want to change all of these buttons to like purple. Then I can just go to the one single place where I define that component, and I can change that to purple. If I were creating a lot of these buttons from scratch, pasting them over and over again 50 times, then I will need to go through each one of those components, and then I will need to change all the colors on them. So you want to build your front-end application in a reusable way that could be consistently used throughout your whole application. Okay. So there's GraphQL here. So I think GraphQL, and there's another one that I can't think of, but I think this is used a lot for like Facebook and Netflix. So a lot of the FAANG companies use GraphQL. So if you are seeking a job in front-end development within FAANG, then I'd say studying QL is something that you should look more at, but that's not something I have a lot of experience with, so I'm just going to skip it. Okay, so I also don't have a lot of experience with PWA, which is Progressive Web Applications. So I'm also going to skip that for now, and then we're going to move on to mobile apps. Developing on mobile applications, the only one that I have had experience with is React Native, which is basically React. It's basically using a lot of the concepts on React, but it's making it for mobile. In my school, University of Hawaii, they teach a mobile class, and the professor who taught the class use Flutter, but I haven't used Flutter before, and they also use Dart. I'd say that if you want to have the experience of building a web application very quickly, then you would probably want to learn something like React Native and React, because they go hand in hand with each other. And if you learn a lot of the concepts in React Native, it's also transferable to when you're applying it to a React web application. If you want to save some time on learning a framework for building mobile web applications, but you also want to stay available on building regular desktop applications, then I would say React Native would be something that you need to learn. Okay, so desktop applications, the last one. The only thing on here that I know of is Electron. So I've co-developed an application that is an application that you could use to transfer data through infinite canvases. The same concept of Figma, but it had a lot of like data science capabilities within it. And it's a web application, but we use Electron, which is basically, it uses the same kind of processes in order for you to access like Google Chrome. But Electron, you can update it to have like more low-level capabilities of accessing like hardware on your computer. So if you are trying to build something that doesn't conform to the browser like guidelines of what you're supposed to do and what you can't do, then something like Electron allows you to bypass some of that. All right, so that's it for the front end topic on the roadmap dashboard on helping you becoming a software engineer, find a tech job. The next thing that I'm probably going to be going over is on backend roadmap. And yeah, thank you all for listening to this video. I really, truly appreciate your time on watching this whole video. And the things that I'm trying to teach you within this video, these guys are supposed to be practical knowledge that makes you more confident in trying to learn how to be a software engineer. So if you are someone who already completed your software engineering degree, or if you just started and you want to learn more about computer science, then this guide is going to help you learn the practical things in order for you to be successful and find the tech jobs. Okay, thanks for watching. Please subscribe and like the video.